What makes the polar ozone hole so massive? Imagine a giant, invisible shield protecting the Earth's surface from harmful ultraviolet rays. Now picture this shield shrinking dramatically over the South Pole each year. What causes such a large and deep hole in the ozone layer? Let's find out. The main reason is the unique climate and atmospheric conditions over Antarctica. During the long winter months, the polar vortex forms, a strong, circular wind pattern that traps cold air over the continent. This vortex keeps the cold, ozone-depleting chemicals contained in a small area, preventing mixing with other parts of the atmosphere. Temperatures in the polar stratosphere drop below -78 degrees Celsius. These extreme cold temperatures lead to the formation of polar stratospheric clouds, or PSCs. These clouds act like tiny chemical factories, providing surfaces for reactions that turn inactive chlorine compounds into active chlorine, such as chlorine monoxide. When the sun returns in the spring, it provides energy to break apart these chlorine compounds. The free chlorine radicals then rapidly react with ozone molecules, destroying them in large quantities. This process is much faster and more intense because of the high concentration of reactive chlorine on the PSCs. Human-made chemicals called chlorofluorocarbons, or CFCs, are the main source of chlorine in the atmosphere. These chemicals were once used in refrigeration, air conditioning, and spray cans. When they reach the stratosphere, they stay there for many years, slowly releasing chlorine that fuels ozone destruction. The stability of the polar vortex also plays a role. A strong vortex keeps the cold air and chlorine chemicals trapped over Antarctica longer. This allows more ozone to be destroyed before the vortex weakens and breaks apart in the spring. When the vortex collapses, warmer air mixes in, ending the ozone depletion season and allowing ozone levels to recover. So, the size of the ozone hole depends on how cold it gets, how long the vortex stays strong, and how much chlorine is present. The colder and longer the vortex remains, the larger the ozone hole becomes. This is why the Antarctic ozone hole is so much bigger and more severe than ozone depletion in other parts of the world. In essence, the combination of extreme cold, isolated air, seasonal sunlight, and human-made chemicals creates the perfect storm for a massive ozone hole over Antarctica each year.